Hi guys, I'm going to compare some different propellers together, see what sort of thrust we get from them. Now, although I've got some real propellers here and I will try them out, the main purpose of this is to compare some of the toy ones that I get off the various helicopter toys and spinner toys and that sort of thing. The garden ornament ones. Those are the ones that I use for lots of my boats. That's the sort of thing they come from. These are sort of helicopter spinner things that you spin up into the air. So these ones come off hair dryers. There's one of my ones made from a popsicle stick. Just bent wood in steam or hot water. These are off little handheld fans, and so they all get a fair comparison. I'm going to take the motor out of this nasal hair removal kit that I bought from the bargain store. So I'll take that out, either glue it or tape it to this lump of wood, put it on the kitchen scales and arrange for the thrust to be pushing down, so the actual air will be blowing up and the thrust will be pushing down onto the scales, so we should be able to read the number of grams of thrust. Now, as I say, these are only kitchen scales, so they're not going to be hundredths of a gram thrust or anything like that. It's just going to be simple grams. And we'll just see how they compare, see which one gives us a good reading. I mean, like that paper one, I don't expect that to give us a very high reading. So first thing we'll do is take this apart. Stick this on here somewhere and we can use it. Before we actually stick it onto the piece of wood to hold it in place, we'll just measure how heavy it is in grams. So it's 16 grams, we'll remember that. We're all set up, ready to go, and I've come across the first problem already. Brand new motor, straight out of that nasal hair trimmer. Should run on a single AA battery. My AA battery is currently measuring 1.38, which is not that good, to be honest, but that's what we've got. Connect it up and nothing happens. Give it a little flick and we're away. So it might wear in as we do a bit more testing, but that's a bit disappointing to begin with. We'll try again. Different motor, same type but a new one. So give it 1.5 volts. Obviously the reading over here is slightly different because we're losing some voltage, but we're getting 0 on the scales. 3 volts. We're getting 1 gram. 4.5 volts. 2 grams. 6 volts. 3 grams. 7.5. 4 grams. What comes after 7.5? 9 volts. 5 grams. 9 volts, 10.5 volts. Still only showing 5 grams. Try that again. Nope, won't go over 5. One of the problems with just using kitchen scales, not accurate enough. 12 volts. 6 grams. So remember, we're just measuring, the thrust is going up, so it's pushing the motor down onto the scales. We'll try a different propeller, and what shall we use? Yeah, that'll be 6 volts at that position. Let's go through them again. 1.5 is nothing. 3, about 1 volt, 1 gram. 4.5, 2 grams. 6 volts, we're getting about 3. We're probably going to lose a bit because these batteries are going to run down. I should be running off a DC supply, I suppose. But we'll stick with it. So 6 volts, we were getting about 3 grams. Yeah. Different propeller. I guess we got to try one of those wooden ones that I made, haven't we? I got 2 of these. Which way do we want? That one's probably the wrong direction. Because I made these, yeah. One's contra-rotating, but this should be the right one. That way. Oh, is it? I'm getting confused. No, that's the wrong one. We want the other one. Okay. Zero it. Okay, 6 volts. 4 grams of thrust. Oh, that went to 5 for a second then. So that one's more efficient than that tiny one. How about this one? Probably wants to go that way round. 6 volts. That's pretty efficient. 7 grams. Sorry, my finger's in the way, isn't it? Yeah. So that one looks pretty efficient. We'll save that. How about one of these ones? Okay. Zero it again. Oh, I forgot to zero the other one, didn't I? We'll go back to that. Come on, 0, 0, 6 volts. 4 grams. Pretty unbalanced as well. Right, remember to zero this one this time. That's okay, 0. Yep, 0, 6 volts. It's given us 5 grams. Just a point while we're doing this, the original question that started all this was, could we use one of these to lift a helicopter? Well, what was that, 16 grams, and the thrust we're getting is about 5 grams so far. try one of these little handheld fan ones. Come on, 0, right, 6 volts. It's given us 4 grams. Let's chuck them away. How about this one? This is off one of those little toy helicopter things. I think this one's, oh, I don't know, let's see. Yeah, that's the wrong way. That's blowing air down. Right, 0, 6 volts. It's given us 3 grams. Right, which way does this one want to go? Zero. That's the wrong way. Zero. About 2 grams. Another little handheld fan motor. Zero. Oh, that's no good. Lift it up a bit. That's not going to work because the blades are touching the... Right, abandon that one. Let's try one of these. Okay, this is a hairdryer fan. 0. That was about 3 grams. Right, I've got some real propellers here. It's actually got a little centerpiece in it. No, it's not going to fit. Okay, I've got an adapter. Little aluminium adapter. Propeller on there. Try and line it up reasonably well. Zero, 6 volts. Well, I think we can see that's the difference between getting a proper propeller and a toy propeller. 9 grams already. And while we've got that like that, try one of these. Getting 10 grams there, double figures. You can hear it's turning slower. What happens if we give it 12 volts for a few seconds? 21, yep, 21 grams. Just out of interest, we'll just turn that over. So that was 21 grams at 12 volts. Only 13 grams with the propeller facing the wrong way. So a good example of, if you are using proper propellers, you've got to make sure they're facing the right direction. And I guess finally we'll try a ridiculous sized propeller, if we can even get it on there. Oh, just the tiniest bit of thread on there. Okay, will we go for 12 volts again? Are we going to hit anything? No, I think we're clear. Oh, need to zero it again. Zero. So we're only getting 10 grams of thrust. It's a much larger propeller, but obviously it's turning much slower because that motor doesn't have much power. So we're really straining that motor now. I think we've probably covered all the options there. Just try that one the other way up. 0, 12 volts. Yeah, we're about halving the thrust if you have the propeller the wrong way round. So back to that one. 12 volts, so 0, come on. 0. We're getting 19 grams there. I think we got 20 just now. It's down to 18. I would guess the batteries are running down a little bit. So, right propeller for the job, and it goes a lot better. But would that have lifted it off the ground? How much was it originally? 16 grams for the motor, and we're getting more than 16 grams thrust now. So it would have got off the ground. But then we have minor things like the weight of the batteries. So for a helicopter, I don't think we're going to get off the ground with one of those motors. And that's the propeller the wrong way round, about half the thrust. I think I've covered it all. I'll try and edit the video to make it all fit. Job done. Feel free to add comments, read the video description for any information I can supply. Job done.